Hello friends, welcome to Success Hub Media. This is Mathematics Made Easy series. This is part 8 of the series where we are learning the secrets you need to know in order to become a genius in mathematics. In today's lesson, we'll be talking about fractions. This is fractions part 2. If you are new to this channel, please like, subscribe, and press the bell icon so you can be notified automatically whenever a new video is released. A quick recap of our last lesson, which was lesson 7, we learned about LCM and HCF. In that lesson, we learned about what LCM and HCF are. We also learned why you need to know LCM and HCF, and we also learned how to calculate LCM and HCF. So we had to digress from fraction part 1 to LCM and HCF because they are prerequisite knowledge you need to have in order to understand this part of fraction we'll be talking about today. So in today's lesson, we'll be learning the addition and subtraction of fractions. We also learn multiplication and division of fractions. So starting with addition and subtraction of fractions, let's take some examples. Let's say we have 1 over 2 plus 2 over 3. In order to solve this fraction, you start by writing out the fraction you have been given. The next step is to take the LCM of the denominators. Denominators are the bottom numbers of each of the fractions we are dealing with. So in this case, our denominators are 2 and 3. So we'll take the LCM of 2 and 3. When we take the LCM of 2 and 3, we'll have a 6. If you are struggling in finding LCM of numbers, do well to check the lesson where I taught about LCM and HCF, which was lesson 7. So the next step is to leave a blank row in your notebook. You draw a line, then you write the LCM you have gotten underneath the line. The next step is to visit each of the fractions that are participating in the addition and subtraction. So on visiting this first fraction, we will divide the LCM we have gotten by the denominator of this first fraction. So when 2 divides 6, we'll have a 3. You multiply the result you have gotten with the numerator of this fraction. So when 3 multiplies 1, we'll have a 3. We'll write the 3 here, standing for this first fraction. We'll write the sign we have here, be it plus or minus, we'll write it here. Then we'll visit the next fraction, which is 2 over 3. When the 3 divides 6, we'll have a 2. You'll multiply the result you have gotten with the numerator of this fraction, which is 2. So 2 times 2 will give you 4. Hence the reason we will have 3 plus 4 as the numerator of this new fraction we are working on. So a quick recap of how we got 3 plus 4. We visited the first fraction, we divided the LCM by the denominator of this first fraction. So when 2 divided 6, we had a 3. 3 times 1 gave us a 3. The addition sign is what we have written here. We visited the next fraction, 2 over 3. When 3 divided 6, we had a 2. We'll multiply the 2 with the numerator and we had a 4. So when we add 3 with 4, we are going to have a 7. So can we leave our answer here? The answer is no. This is an improper fraction. It is improper for a child to carry his father. So it is improper for 6 to carry 7. So we are going to divide 7 with 6. When 6 divides 7, we'll have a 1, which is a whole number. We'll have 1 as our remainder divided by the denominator, which is 6. So we are done with 1 over 2 plus 2 over 3, which has given us one whole number, 1 over 6. Let's take another example. Say we have 3 over 4 plus 2 over 4. So we are going to start by writing the fraction. We'll take the LCM of the denominators. Denominators in this case are what? Are 4 and 4. So when you take the LCM of 4 and 4, you have a 4 as your answer. So the next step is to leave a blank row. You draw your line and you write your LCM underneath the line you have drawn. So the next step is to visit each of the participating fractions. So on visiting this first fraction, we are going to divide the LCM we have gotten by the denominator of this first fraction. So when 4 divides 4, we are going to have a 1. When you multiply the 1 you have gotten with the numerator, which is 3, 1 times 3 will leave you with 3. You move the sign you have here down to this place. You visit the next fraction. When you divide with the LCM with the denominator of this second fraction, when 4 divides 4, you have a 1. You multiply the 1 with the numerator which you have here, which is 2. So 1 times 2 will leave you with 2. So we now have 3 plus 2. A quick recap of how we got 3 plus 2. We visited the first fraction, we divided the LCM by the denominator, we had a 1, we multiplied it with the numerator, we had a 3, we moved the sign here down to this place, visited the next fraction, divided the LCM by the denominator, which is 4. When 4 divides 4, you have a 1. We multiply the 1 with the numerator, which is 2, we had a 2. So 3 plus 2 will give us 5, divided by 4. This is an improper fraction which will convert to a mixed fraction to have one whole number, 1 over 4. Let's take a look at another example. Now we have 5 over 6 minus 2 over 9. The steps remain the same. Write the question you have been given. Take LCM of the denominators, which is 6 and 9. LCM of 6 and 9 will give you 18. Leave a blank row, draw your line, write the LCM underneath. Visit the first fraction. When 6 goes into 18, you have 3. When 3 multiplies 5, you have 15. You move your minus sign to this place. When 9 divides 18, I'm on the second fraction now, I'm visiting the second fraction. When 9 divides 18, you have a 2. When 2 multiplies 2, you have a 4. Hence the reason why we have 15 minus 4. And when 15 minus 4, you are going to have 11. We now have 11 over 18. Can we leave our answer here? The answer is yes, because this is a proper fraction. It is proper for a big number to carry a smaller number. Let's take a look at another example. Now, we have 2 whole number 1 over 5 plus 1 whole number 3 over 5. The first thing you do is to rewrite the question that has been given. The next thing you do at this stage is to convert these improper fractions to mixed fractions to improper fractions. I beg your pardon. So when you convert 2 whole number 1 over 5 to improper fraction, we are going to have 11 over 5. When you convert 1 whole number 3 over 5 to improper fraction, you are going to have 8 over 5. Just in case you are in doubt as to how we converted from here to here, when 5 multiplies 2, you have a 10. 10 plus 1 is 11, so it becomes 11 over 5. 5 times 1 is a 5. 5 plus 3 is 8. We now have 8 over 5. So the same steps we have learned in the previous examples is what we are going to take at this stage in time. So we take the LCM of the denominators, which is LCM of 5 and 5, which will give us a 5. So we'll leave a blank row, we'll rule our line, we'll write the LCM here. We'll visit the first fraction. 5 into 5 will give us 1. 1 times 11 will leave us with 11 here. The addition sign, will move it here. Visit the next fraction. 5 into 5 is a 1. 1 times 8 will leave us with 8. So we end up having 11 plus 8 as our numerator. 11 plus 8 is 19. Can we leave our answer like this? The answer is no. It is improper for a smaller number to carry a bigger number. Hence the reason why we'll convert this to a mixed fraction. So when 3 divides 19, we will have 3 whole number. There will be 4 as remainder divided by 5. Let's take a look at this other example. We now have 2 whole number 3 over 4 plus 3 whole number 2 over 5 minus 1 whole number 2 over 3. The steps are the same. We'll start by writing the question. We'll convert all the mixed fractions to improper fractions, and we'll have what we have written here. The next step is to find the LCM of the denominators. The LCM of 4, 5, and 3 is 60. So you leave a blank row, you draw your line, you write the LCM underneath the line. When you visit the first fraction, 4 will go into 60 how many times? 15 times. So you multiply 15 with 11, you have your number here, you move this addition sign to this place, visit the next fraction, 5 will go into 60 how many times? 12 times. You multiply the 12 with 17, you write your result here, you move this minus sign to this place, you visit the third fraction, 3 will go into 60 how many times? 20 times. 20 times 5, you write your result here. So we end up having 165 plus 205 minus 100. I hope you are all clear. By the time you add and subtract the numbers at the numerator here, you will have 269. Can we leave our answer like this? The answer is no. 60 cannot carry 269. It is improper. So we have to convert it to a mixed fraction. So as mixed fraction, we are going to have 4 whole number 26 over 60. Now we are moving to multiplication and division of fractions. So we have an example here to multiply 2 over 4 times 3 over 6. So we'll start by writing out the equation we have been given, which is 2 over 4 times 3 over 6. When it comes to multiplication, the approach is different. Okay? So in multiplication, there are certain ways you have to look at the fraction. One of the ways is to look at each of the fraction from numerator to denominator. That's like this. You look at the other fraction from its numerator to denominator. You are trying to find out if there is a number that can divide this numerator that can equally divide its denominator. When you are done with this fraction, you move to this next fraction. You look whether there's a number that can divide the numerator that can also divide the denominator. Another way is to look diagonally, just like the multiplication sign. You also look in this direction to see if there's a number that can divide this denominator that can also divide this numerator. And you also look this other way. So the ways you look at multiplication of fractions are like this. You look like this, you look like this, you can also look like this and look like this. Okay? So it all depends on where you decide to start from. No approach is wrong, provided you know what you are doing. Okay? We are going to solve this particular question in two different ways. We are going to solve it by looking at the fractions from up to down, and we are going to solve it by looking at it diagonally and see whether we'll have the same answer. Okay? Now let's look at these fractions from up to down. When we look at 2 and 4, we see that there is a number that can divide 2 that can equally divide 4, right? Which is what? 2. 2 is that number. So when 2 divides 2, we'll have a 1. And when 2 divides 4, we'll have a 2. Equally, when we look at 3 over 6, there is a number that can divide 3 that can equally divide 6. That number is what? 3. So when 3 divides 3, we'll have a 1. When 3 divides 6, we'll have a 2. So it therefore means that this fraction we are dealing with has now changed to 1 over 2 times 1 over 2. Okay? So we now have 1 over 2 times 1 over 2, because 2 has divided 4 to give us 1 over 2, and 3 has divided 6 to give us 1 over 2. So the next step is to also look diagonally whether any number can divide. If we look at 1 and 2, there is nothing that can divide 1 that can also divide 2. If we look at this 1 over 2, there is nothing that can divide. So at this point, where you cannot find any number that can divide, whether looking vertically like this or diagonally like this, at this point, the next thing you have to do is to multiply the numerators and the denominators. So when we multiply 1 and 1, we'll have a 1. We'll have a 1. When we multiply 2 and 2, we'll have a 4. Now, alternatively, you can also decide to look at this same question we are having. We want to solve it in another way. Let's assume another person decides to look at the numbers like this in his first approach. In other words, remember that while we were solving the last method, we started by looking at it vertically like this. Another person might decide to start by looking at this direction. It doesn't mean that the way the person is looking at it is wrong. It's still right, provided at the end of the day you look at it in both this direction and in vertical directions like this. Okay? All right. So if we decide to look in this direction as our first approach, we'll find out that if we look like this, comparing 3 and 4, there is no number that can divide 3 that can also divide 4. So you can say that there is nothing that can divide in this direction, right? We move to this direction. Looking at 2 and 6, there is a number that can divide 2 that can also divide 6. So we'll start by saying 2 divide 2, we'll have a 1. When 2 divides 6, we'll have a 3. Okay? So now the fraction will become 1 over 4 times 3 over 3. And when you also look at 3 over 3, you can find out that there's a number that can divide 3, which is 3. The 3 can also divide 3 to give us a 1. So we end up having our fraction to be 1 over 4 times 1 over 3. Okay? So we now have 1 over 4 times 1 over 1. All right. So in moving further, since there is no number that can divide in this direction again, and there is no number that can divide in this vertical direction, the next thing is to multiply the numerators and the denominators. So when 1 multiplies 1, we'll have a 1. When 4 multiplies 4, we'll have a 4. As you can see, the same answer we've had here is the same answer we are having here. So it doesn't matter how you decide to look at it first. The general idea is that at the end of the day, when you are multiplying fractions, you ensure, all you need to do is to ensure you look at it in the vertical directions. Say you have A over B times C over D. Make sure you look at it in the vertical directions, and you also look at it in the diagonal or in the cross format. So with that, you will be rest assured that you are on the right track. Okay? All right. Now moving forward. Let's assume we have let's have another example, which is 3 over 4 times 1 over 2. So we'll start by writing out the fractions we have been given. The next step is to look in the directions we have said earlier on. So when you look at it in this direction, you see that there is no number that can divide. When you look at this direction, no number can divide. Look at it in the vertical direction, there is no number that can divide. So all you need to do is to multiply your numerators, which is 3 times 1, 3. Multiply your denominators, which is 4 times 2, 8. So this is your answer. Okay? Now this is another example. 3 over 4 times 4 over 6. So we'll start by writing out the fractions. The next step is to look at the directions we have just learned. We can decide to look at this direction first. We can see that 4 can divide 4 to give us 1 and 1. And we can also look at this direction. We can see that there is a number that can divide 3 and equally divide 6. So that number is 3. Okay? So the reason why we are having a 1 over 1 times 1 over 2 is simply because when 3 divides 3, we have a 1. When 3 divides 6, we have a 2. Hence the reason why we now have 1 over 2 here. And when 4 divides 4, we have a 1. When 4 divides 4, we have a 1. Hence the reason why we have 1 over 1 times 1 over 2. When you look at the directions again, you find out that there is no number that can divide. So you just multiply your numerators and your denominators. So 1 times 1 will give you a 1. 1 times 2 will give us 2. So our answer is 1 over 2. Now let's take a look at division of fractions. Say we have 2 over 4 divided by 6 over 3. In order to solve this problem, we'll start by writing out the fraction we have been given, which is 2 over 4 divided by 6 over 3. The next step is to change the division sign to multiplication sign. When you change the division sign to multiplication sign, there is a magic that will happen to this fraction, which is at the right hand side. The magic is such that the denominator will become the numerator and the numerator will become the denominator. So in changing 2 over 4 divided by 6 over 3 into multiplication, we are going to have 2 over 4 times 3 over 6. Take note of what has happened to the numerator and denominators. So from here, we apply the rules or steps of multiplication of fractions, which we have learned in previous examples. So in taking a look at this fraction, we can decide to look at the fractions like this vertically first. So in looking at the fractions vertically like this, we'll find out that there is a number that can divide 2 that can also divide 4. That number is 2. There's a number that can divide 3 that can divide 6. That number is 3. So which means I can say 2 into 2 will give us a 1. 2 into 4 will give us a 2. I can say 3 into 3 will give us a 1. And 3 into 6 will give us a 2. So we end up having 1 over 2 times 1 over 2. Hence the reason why we'll have 1 over 2 times 1 over 2. When we look at the different directions we have established before now, we'll find out that there is no other number that can divide in any of the ways we have learned before now. So the next step is to multiply the numerators and denominators. 1 times 1 will give us a 1, 2 times 2 will give us a 4. Hence the reason why we have 1 over 4 as our answer. Let's take a look at another example. Say we have 2 over 5 divided by 4 over 3. So we'll start by writing out the fraction we have been given. The next step is to change the division to multiplication sign and to swap the numerator and denominator positions. The next step is to look at the different directions we have learned before now. Looking at this direction, there is a number that can divide this number and this number. When 2 divides 2, we'll have a 1. When 2 divides 4, we'll have a 2. Hence the reason why we now have 1 over 5 times 3 over 2. So looking at the different directions we have learned before now, there is no other number that can divide in any of the directions. So the next thing we have to do is to multiply the numerators and multiply the denominators. So 1 times 3 will give us 10. 1 times 3 will give us 3, and 5 times 2 will give us 10. Hence the reason why our answer is 3 over 10. So you can try the following. You can write your answers in the comment section. If there is any part of this tutorial which you are not very clear with, you can let me know in the comment section so I can give you clarity in your area where you don't understand. And if there is any topic in mathematics you would like me to make a tutorial on, feel free to write it in the comment section. Don't forget to like, subscribe, and press the bell icon. Thank you for listening. Till we see you again.